What do these pictures have in common? They're all real images taken in space. But look closely, where are all the stars? Every time we see rocket launches, moon landing photos, or footage from the International Space Station, the background looks completely black. No sparkling stars, just darkness. That simple detail has fueled one of the biggest conspiracy theories in history. So let's break it down properly and understand why this happens. Not just by looking at cameras, but also by understanding what astronauts actually see with their own eyes. Astronauts describe space as an unfathomable blackness, a deep, textured darkness that feels almost tangible. The sky isn't glowing with stars the way we imagine, it's pitch black. On February 7, 1984, 5 astronauts aboard the Challenger space shuttle prepared to make history. For the first time ever, an astronaut would perform an untethered spacewalk. No safety line attached to the spacecraft. Bruce McCandless stepped out of the cargo bay wearing a jetpack and famously said, "It may have been one small step for Neil, but it's a heck of a big leap for me." The pilot, Robert Gibson, grabbed a Hasselblad camera, set the exposure, and captured one of the most iconic images ever taken in space. McCandless floating freely above Earth. But again, where are the stars? Here's the key: it's not a camera malfunction, and it's not a cover-up. It all comes down to exposure. Every camera has something called shutter speed, the amount of time the sensor is exposed to light. The longer it's open, the more light it captures, and the brighter the image becomes. In space photos, the subject isn't the stars. It's the astronaut, the spacecraft, or Earth. And those objects are extremely bright because they're reflecting direct sunlight. Just as bright as daylight on Earth, stars, on the other hand, are incredibly faint compared to a sunlit astronaut. If you expose the image properly for the astronaut, the stars are too dim to appear. If you expose for the stars, the astronaut becomes completely overexposed, washed out in white. You can't properly capture both in a single standard image. One has to give. That's why stars don't show up in most space photos. Not because they aren't there, but because of how light and exposure work. And here's something even more interesting. Astronauts themselves often report not seeing stars with the naked eye while in orbit or standing on the moon's sunlit surface. Because your eyes work just like cameras. In bright environments, your pupils shrink to reduce incoming light. On the moon's reflective surface, sunlight is intense. Your eye is adjusted for that brightness, which makes faint stars effectively invisible. But place an astronaut in deep shadow and wait long enough for their eyes to adapt to the darkness, and the stars slowly begin to appear. Apollo astronauts reported that the only time they could clearly see stars from the moon was when standing in the shadow of the lunar module. Once their eyes adjusted, the universe revealed itself in full clarity, free from atmosphere and light pollution. Even future missions to the lunar South Pole will experience the same effect. In bright regions, the sky will still appear inky black. But inside dark craters, away from reflected sunlight, astronauts will see a breathtaking, unobstructed view of the cosmos. And if you truly want proof that stars can be photographed from space, look at long exposure astrophotography taken aboard the International Space Station. When cameras are set specifically to capture faint light, the stars appear beautifully. sometimes in ways impossible from Earth due to our atmosphere. So the next time someone claims that the absence of stars in space photos proves a conspiracy, you'll know the truth. It's not mystery. It's not deception, it's physics.